Hey guys, today the session is about segment routing.
Looks like some voice problem.
Hey guys, yeah, so we are back online. So this is an introductory session. I don't assume that you know anything about segment routing at all. Further sessions, yeah, we need to know a little bit. So this session is introductory, and if you have any doubts, feel free to stop me on the WebEx or in the room, because I think it's important to understand these fundamentals. The further sessions will be based on these fundamentals. All right. So, okay, we get started with the introduction. The first thing is why segment routing. So before any technology is invented, a lot of money, people, resources go into it, right? So there has to be a big why. The why is SDN, software-defined networking. Currently, the way we do networking is destination-based, as in the routing table, all the routes, etc. It's always about reaching the destination. If you had to not send traffic based on destination alone, then you had to do RSVPT, etc. RSVPT is not very scalable. So, I mean, huge deployments of RSVPT aren't there simply because it's not scalable. As the network grows bigger, RSVPT is not helping the cause there. So segment routing, it scales. I mean, segment routing scales a lot. So it gives you software-defined networking at scale. That's what segment routing does. Yeah, on WebEx, you're able to hear me, right? Okay. The phone is a bit far away, that's why. Okay.
Yeah, Krishna.
Okay, perfect. And the other thing with segment routing is because it's SDN, you don't route just based on the destination IP. You can have multiple criteria to route traffic. And then, as usual, because it enables SDN, the new services, so service providers, for them, it's a new business opportunity. So open standard SDN technologies as of today are OpenFlow and then segment routing recently. OpenFlow didn't catch on because it's quite complicated and I mean, there are other complexities. Segment routing is the one that SPs are happy about because it can be done at scale without much additional complexity. In fact, it reduces complexity in the network. We'll see how. So what segment routing provides is it's an MPLS-based architecture. I mean, we're not talking about SRv6 today, so we'll just focus on MPLS. It's an MPLS-based architecture with distributed intelligence and centralized optimization. We will again see how. So all these are buzzwords at the moment. Again, very easy to move to SDN. No need to rip and replace because you use the existing MPLS data plane. You don't have to get new ASICs or etc. You just need to upgrade the software on all the routers. That's it. It works. Because data plane, nothing changes. And then how SDN, so segment routing alone does not achieve SDN. Segment routing alone does not achieve it. You need to use segment routing traffic engineering. But to get there, first we need to understand what segment routing is, and then eventually we'll get to SRT. So currently, how do you do networking, right? I mean, how do you do MPLS networking? You have an IGP, then you have LDP. LDP is the one that generates the labels and then distributes labels to everybody else. So now we have two things. You have an IGP and then you have LDP. When you have both, you have issues. You've heard of IGP, LDP sync issues before, right? So you have all those problems. You have an extra control plane protocol, LDP. LDP again creates a separate UDP session, TCP session, etc. It's added complexity. With segment routing, we get rid of LDP. The IGP OSPF or ISIS, which you're already using today, is just extended to advertise labels also. So just the IGP can take care of advertising labels as well. So along with that, it provides the standard 50 millisecond fast reroute, microloop avoidance. The specialty about segment routing based FRR is it gives 100% FRR coverage. Currently, if you use IPFRR or if you use RLFA, RLFA is what is generally used today. RLFA gives you about 80 to 85% coverage because it's topology dependent. But with segment routing, you give any topology to it, any sort of connections, it will give you 100% FRR. We'll see how this is done in the next session, which is on the next slide. Currently, this is a specialty about segment routing. It gives you 100% FRR. Okay, so as we spoke, so today how routing is done? Destination based. Everything is destination based. So the network has all the intelligence. The packet comes in. The packet does not have any intelligence, as in the packet does not have much state. It just says, this is where I want to reach. The network decides how the packet has to reach the destination. That's how all our networking is built on. The other extreme is, packet has all the info about how it wants to get routed through the network. I mean, we don't use that much today because all of our routing is destination based. But the other extreme is, packet has all the info about how it wants to go, network is dumb. It sees where the packet says, this is the next hop I want to go to. The network sees the next hop, just sends it there. This is not scalable, so it has never been done. This is called source-based routing. But what segment routing does is, segment routing is a hybrid. It uses the best of both worlds. In the sense, the packet has enough information to tell that these are the points in the network I want to touch, not necessarily exact hop by hop. So you have 10 hops. The packet need not tell all the 10 hops. Packet may say, I want to go to 2 hops and then reach my destination. So that much info the packet can give. And then, now out of 10 hops, packet has specified only 2 hops, but there are a lot of hops in between, right? That intelligence network has. So the network can route between the points that the packet wants to go. Getting it right so far? All good?
No, but what is the advantage of this? Like, anyway, the packet has to go through that network someday.
Correct. I mean, so since currently what we do is purely destination based, we don't have flexibility. As in, we only look at the destination IP, and maybe if you're using PBDS, look at the DSCP marking, and then send the traffic on. But with segment routing, we can actually choose whatever path we like within the network. I'll come to that, but that's a big advantage. Okay, so segment routing, the way segment routing, identifies the network elements is using segments. Everything is segment for it. That's why it's called segment routing. You divide your network into segments, and then you route based on segments. Okay, so segments can be links or nodes or a combination of links and nodes. So currently, the way segment routing is done today is a link is a segment, node is also a segment. So if you see this diagram here, right, you have multiple routers. So each router is a segment in the network. And then you have multiple links between the routers, right? You have links between the routers. So those links are also segments. So with segment routing, I mean, since every node and every link is a segment, the packet can give the list of segments it wants to go through. That's how packet can go through anywhere in the network. I mean, any path in the network it can choose, because it's telling I want to go to this segment, then this segment. Segment is either a node or a link. And then if the segments are not directly connected, then the routing in the network, which is the today's destination-based routing, can send between those two segments. Again, segments again, we have local and global segments. So, okay, again, going back to this network, right? A global segment is something which is global in the network, as in it has to be unique. Say you have a router name, right? Or a router ID. If you're using OSP for ISIS, you have a router ID. Router ID is global, right? You cannot have the same router ID on 2 nodes. It's not accepted. I mean, it'll accept, but you'll have a lot of issues. So that way, every node that gets a segment ID, that is unique in the network, that identifies that particular node. The links that are connected in today's segment routing, they are local, as in the link segment ID is local to the box. It's local as in, okay, we'll come to it, just have this understanding for now. And since this is MPLS data plane, the segment ID is an MPLS label. Node gets a label called node SID. SID is segment ID. Node gets a label called node SID. It's a loopback. It's a label for the loopback. That's a global label. And every interface on which you have an IGP adjacency, that also gets a label. That's called adjacency set. That is local. We'll again come to more details on it. The local segment is only the originating node understands what to do with it. If it gets a packet with that label, only the originating node knows what to do with that packet. We are coming to a lot of examples, so this understanding will get clear. Same thing, segment is represented by segment ID, IGP link, adjacency set, IGP prefix is prefix set, but currently in segment routing, okay, so how does LDP work? So you have 1000 prefixes on the box. LDP will assign a label for each of the prefixes, right? Segment routing doesn't do that. Segment routing will not assign labels to prefixes. So yeah, it only assigns labels to the loopback, which represents the node set, or it assigns labels to the links, adjacency set. It does not assign labels to prefixes. Again, if you have doubts or you're lost somewhere, feel free to stop me. But as I said, examples are coming, so this will become much clearer. So,
yeah, can you please just spend 20 seconds on this one, because assigning labels to only the nodes, not to the prefix, is interesting. So it will be good if you can spend a few minutes on this, or a few seconds on this.
Sure. Yeah, give me about 10 minutes. About 2 to 3 slides later, right? I'll explain it. Or if you want, let me explain it right now. Let me go back to this guy. Okay. See, as I said, right, the point of segment routing is to define a traffic path for the packet, right? It's not destination based. And now what is LDP? LDP is destination based, as in the IGP routes. Routes are always destination based, right? It's about a destination. LDP assigns a label to that destination. So the current way of networking is destination based. That's the reason LDP has to assign a label for each prefix. Pretty much means LDP is assigning a label for every destination. Now, segment routing is not destination based. That's not its intention. Otherwise, you can't do SDN, right? So with segment routing, all that we want is, we want the packet to go to this node or this link. Our whole point of segment routing is to go to a particular node or a particular link, or a combination of links and nodes. So that means we need identifiers for the link and node, not for the destination. You're getting this slowly, or is it somewhat clear?
So this is how, like earlier in circuit switching, right? It always happens, right? You take the interface and you take the node. This is a cross connect that has to happen between this and this. I don't need to know where the circuit originates and ends.
Right. Right, yeah, exactly. This is something similar. The point is not destination-based routing. It's a paradigm shift in the way you think of networking. Okay.
So is it like in OSPF you take a stub area or something? Segment is like that area where internal nodes need not know everything in the whole network. Whereas they need to know the set of nodes which are specific to that particular segment and not beyond that.
Yeah, somewhat similar.
Okay.
So the thing is, okay, I guess I better show, I had a diagram. We'll come back. Okay, let's come to this. Okay, so this is what I wanted to show later on. Now, R1 has a node set of 16,001. All right, so similarly, R2 16,002 and so on. So this is my network the example that I wanted to give. Enlarge it. Okay.
You can do that.
It's on WebEx too.
Yeah, you can zoom it in WebEx.
Oh, we can? Okay.
I know. It's okay?
Let's show WebEx.
Okay.
Yeah. It does. Does this have a pointing tool on WebEx has it? Does it have a pointing tool? I don't know. No, but the thing is it has to be shown on WebEx. Otherwise, it won't make much sense.
I think you can show it on the screen.
Okay.
And people who are on WebEx, they can join it.
Okay. Okay. I'll come here. Okay. So, say I have traffic coming into R1 and exiting R6. Okay. Currently, with destination-based routing, what happens? It takes the best path. Say all links are equal cost. The best path is just straight link. Okay. But I want traffic to go like this. Then what do I need to tell the packet? I need to tell the packet. I need to say, the packet should have a label telling R8 slip 16,008. It needs to go here. After that, I need to tell the packet go to 16,004, then go to 16,002, which is R2, then go to R3, and then finally go out. So this is not
a redundant link between the two nodes, right? So
yeah,
that's where you play the interface ID or
yes.
node, like a link ID.
Link ID is true. That's so. This is the reason I don't need to assign labels to a prefix. Say I may have 1,000 prefixes behind R6, but to go to R6, I'll just be using this link. I'll just be using R2, R1 to R4 to R6 link for all the 1,000 prefixes, right? The path doesn't change for me. If I'm getting 1,000 prefixes from R6, and my traffic is incoming into R1. R1 to R4, R4 to R6 is my best path for all the 1,000 prefixes. But say out of the 1,000 prefixes, 500 prefixes, I'm okay for them to take the best path. But for the rest 500 prefixes, I want to take some other path. In that case, I can go to R8, R4, R2, R3, R6 using a label stack. We'll come to that. So segment routing is all about which path I want to take. It's not about which destination I want to go to. So that's the reason I don't need to assign labels to every destination prefix. I just need to have labels as per the path I want to take.
So here is the remaining 500 prefixes, right?
Mm-hmm.
You wanted to take a different path.
Right.
So is it not a link prefix based? So how will you?
No, so it is prefix based. Okay. This can be done using SRTE. Okay. Segment routing traffic engineering has something called as a binding state. We'll again see that. The whole point for me is I have two TE tunnels. One TE tunnel. The best path, there is no need of a TE tunnel. R1 to R4 to R6 is just straight IGP. No need of a tunnel for it. But say I want to go from R1 to R8, R4, R2, R3, right? Then I build a tunnel. And then for those 500 prefixes, I will put that binding set. Another label which is go into the tunnel now. And the way I build the tunnel is based on the node ID or a link ID.
Something different from a regular TE, like what you say is that regular TE tunnel also you give a static path.
Regular TE tunnel too, we can give static path, but the problem with the regular TE tunnel is, say I build a tunnel from R1 to R8, whatever, right? RSVP, it works on path message. So path message to this guy maintains state of the tunnel. Path message, so every router along the path of the tunnel has to maintain state. But in segment routing, only the head end has a state. These guys don't even know that. Say any other router in the path of the tunnel does not even know that it's part of a tunnel because there's no state to it. There's no signaling to it. Signaling or whatever state is maintained only on the head end. So that way your cores can scale to thousands and thousands of tunnels because the core does not maintain any state. In case of RSVP, if you have 1,000 tunnels, that means all these routers are maintaining 1,000 states because RSVP is signaled. That's one advantage of SRT compared to RSVP. Again, so segment routing does not need LDP. It does not need RSVP as well. It does the functionality of LDP. It does the functionality of RSVP. It does the functionality of RLFA. Three things. One protocol does all these three things. So you can get rid of RSVP, you can get rid of LDP, you can get rid of RLFA with segment routing.
What is the label when you choose on the R1? It is going to be the low state value, how it is going to be?
Yes. So, okay. The prefix coming in does not have a label at all.
Yeah.
Right? So, in that case, it will go as plain IP. So, we have 1,000 prefixes. There's no label. It will go as plain IP. The functionality comes when you want to send them over a particular path. So, segment routing is all about getting the path you want to take. It's not about destination-based routing, right? So, in this case, 1000 prefixes, it will forward as plain IP. There won't be a label to it because segment routing is not allocating a label.
In a different path.
If I'm taking in a different path, then what I'll tell is, say, so I have 1000 prefixes means 1000 streams are coming in. Correct, right? So 500 streams, which I want them to take the best path, go by plain IP. For the other 500 streams, which I want to take a different path, put the binding set or the label of the tunnel. Did you get it? See, so this all goes into SRT. I wanted to do SRT much later. So the tunnel, SRT tunnel has a label. So if it comes with a particular label, or auto route announce also works. So you have auto route announce in RSVP, right? You have auto route include here. So you can say for these set of prefixes, go over the tunnel. That is also possible. Or for the traffic that you want to take a particular path, put the binding set of the TE tunnel. So who will put the binding set of the TE tunnel? All that will come to it.
No, let's not talk about that binding set or anything. Say for example, take an LDP configuration. Now you are saying that it will be the LDP.
Yes.
For now, let's not talk about that. Once you enable LDP, for all these 1000 prefixes, when you look at the R1, it will say each and every prefix a different label, correct?
In LDP, correct.
So now, when you are replacing that LDP with SR,
correct.
how does that each prefix is going to look into it? Is what I'm asking.
It will look at the normal routing.
Only the plain IP routing.
Plain IP routing. Okay, so first thing, why was LDP invented? Why did you need LDP? For services, right? For MPLS services, L2 VPN, those kind of services is primarily where we need LDP. Right? Otherwise, LDP was initially created for FRR purpose. But later IPFRR came, so that functionality of LDP is no longer needed. Now we primarily use LDP for services, L3 VPN, L2 VPN, etc. Right? So that services are always loopback to loopback.
Yeah.
Correct? They're not interface based. For a loopback, anyway, I'm generating a label. That's the node set. So I can use, say, if I have an L3 VPN between R1 to R6, I can use the node set of R6, which is 16,006.
That is what I'm asking. Yeah, how does it represent in the output is what I'm asking.
Output will be a label. It will be a label. If it is a service is between loopbacks. But if you're talking about plain IP, then in that case it will go as plain IP forwarding. There's no need of a label for it technically. You need a label if you're doing services. Right? For services, it will use that.
Who will be pushing that label, the north side ID of the remote PA? Like, who will be pushing that?
This guy will know. So I am using OSPF for ISIS, right? So OSPF for ISIS will distribute all these labels. IGP will do it. So R1 will know what is this link's label, what is this node set, everything. The entire topo label R1 will know through IGP.
Hey, Prabodh, I had the same question. For an example, this R1, R2, we are saying label 24,000 for the adjacency seed.
Mm-hmm. Sure. The point is, we have jumped too far ahead. I want to go back. I want to tell what is adjacency set first. I mean, if you have a particular question, Dakshesh, please go ahead.
No, I mean, I will wait for that. I wanted to know how the labels are distributed through IGP in detail. So I will wait for that.
Sure. I have that in detail. Yeah. Yeah. So all the binding set, all that is here. I mean, we'll get to it. Okay. Representing segments. I think we can move to the next slide, right? Okay. Coming to the label space. This is particular to XR routers. In XR routers, 0 to 15, I think that's the RFC standard, reserved for special. In XC, label allocation starts from 16 onwards. But in case of XR, 16 to 15999 is reserved. The dynamic label allocation starts generally from 16K. But if your XR software is enabled with segment routing, by default, it will reserve 16,000 to 23,999 for segment routing. And then the dynamic label allocation starts from 24K onwards. This is something I want to do. The data point, that's it. Because you'll see all nodes starting from 16,000. Then you shouldn't wonder why 16,000, right? That's the reason. Okay, now we come to adjacency set. So adjacency set represents an IGP adjacency. It doesn't represent a link exactly. So you have two links between two routers, you have two links. Only on one link you have OSPF enabled or ISIS enabled. On the other link you don't have anything enabled. In that case, only on that link where the IGP adjacency is present, the adjacency SID is allocated. It does not mean that for all links on the router it will allocate. It will allocate only on those links which have IGP enabled, and there's a peering.
So basically, it will match with the neighbor. Wherever you have neighbors on the link, that will be.
Yeah, I mean, so if I have 5 links to the same neighbor, I'll still have 5 adjacencies.
5 different.
Yeah, 5 adjacencies. It's a per link thing, but the point is I need to have a neighbor across the link. If I don't have a neighbor across that link, then I'm not going to allocate the label.
So if you're not running IGP, then no.
If you're not running IGP, then I mean, so segment routing needs IGP to be there. I mean, it's completely dependent on the IGP.
Okay. And is the label exchanged, or it is through what mechanism are you going to cover that?
Sure. So I have details on that, but basically what happens is, say if it's an OSPF, so OSPF there is a link state update message which is exchanged between the neighbors. So in that link state update message, there are new LSAs and TLVs defined,
Okay.
which will exchange these labels.
Got it. Okay.
Yeah. Okay. Say for example,
only for OSPF and ISIS for IGP, or
no, only OSPF and ISIS for now. Only. No, BGP has. BGP is not an IGP. So BGP also has segment routing, but BGP is more from a service and yeah. So we'll do the BGP thing a bit late. So currently, in terms of IGPs, it's only OSPF and ISIS because they are link state protocols. I mean, the point is you need a link state protocol. Even for RSVPT, you need a link state protocol. For segment routing as well, you need a link state protocol. Protocols like RIP, EIGRP, which are distance vector, they're not suitable at all. Yeah.
The reason we didn't do the same kind of signaling in the LTP as an extension, and we moved to the IGP extension to reduce the overhead of running one more additional layer.
Exactly. This reduces the overhead. Yes. I mean, so one of the
benefit of having it directly on the IGP.
So this is what service providers want. So service providers want as much reduced complexity as possible. So when segment routing was designed initially, right, it was done in consultation with multiple service providers.
So it's only mainly a config creation reduce cost, right? Anything with respect to the overhead in terms of control.
Label space will reduce, right? So because we are not, for prefix, we are not allocating the labels.
Correct.
Per node or link, I think the label consumed for the network.
Consumption will go down. No, but label stack will be more now. We will see the label stack increasing. So coming to your question, see, having LDP and IGP has worked so far, but it's an additional layer of complexity. And segment routing is not the point of segment routing is not to replace LDP. Point of segment routing is to bring path control into the network.
Kind of just the way like you enable SR
Correct.
along with your IGP.
Correct.
You enable it along with your LDP. Apart from the configuration part.
Oh, configuration, that's it. For configuration, you don't need LDP. You enable segment routing under the IGP directly. Is that the question, the config wise, or you have a different question?
One more additional signaling is what we end up in.
With LDP, you have an additional signaling. In case of segment routing, there's no additional signaling. IGP takes care of it. In IGP, anyway, using update messages, you exchange the prefixes and all that, right? Along with the prefix, if you're advertising a loopback, advertise the node SID label along with it. Well, right? And
So is the node SID labels are to be advertised? Is it explicitly?
Yes.
Because they're global. Everybody, every other other routers in the domain knows about rest of the nodes and their SID.
Yes.
Nodes.
Yes. They know.
And that's being advertised through the IGP.
Yes.
And if some of them not running IGP between the two nodes in the network, they are directly connected, not running any IGP, they wouldn't be able to participate in this then.
Yes, they won't be able to participate then.
Okay, thanks.
So they're different. Adjacency SID represents an IGP adjacency, like a link. I mean, I'm saying links, but technically, as I said, on that link you need to have an IGP adjacency. So you have 3 links, but you have OSPF running only on one link, assume. Then only on that link the label will be generated. But to make it simpler, right, I'll just call it link now. When I say link, assume that there's an IGP adjacency on it. So here I have 3 links. So I have 3 IGP adjacencies. So there'll be 3 adjacency seeds. For example, if you see this, and each router will generate an adjacency seed. It's not that both of them will decide and generate one label. It's not like that. R1 will generate one label independent of R2. So R1 is generating one label for that link. R2 is generating a separate label for that link. Yeah. So the LDP generates for prefixes, not for links. That's a small mandate.
On your previous diagram, this were the same on either side, so I was little confused. So
oh no, okay. So it can be same, it need not be same, because in XR, right, the dynamic range starts from 24,000.
Correct. No, I got it, but looking at that, I thought they exchange, negotiate and agree on something, but looks like that need not be the case.
That need not be true. I mean, the reason I wanted to show it like this is, sometimes it can be same, sometimes it can be different. So I thought I'll mention both.
No, that is fine to show this different, makes it clear. Thanks.
Okay. So in this case, R1, say for adjacency 1, R1 is allocated 24,000, R2 is allocated 24,001. I mean, this is quite dynamic and I won't say random, but whatever is free from the dynamic label range, whatever is the first free, it will allocate. It can be same, it need not be same, depends. So here we have three adjacency seeds, 3 per router. Okay. So
to be different for the other direction traffic?
no, so the label need not be different. All I'm saying is each router allocates a label. So 24,000 onwards, the dynamic range starts. Say R1 has not allocated even a single dynamic label so far. It's always local. This is advertised to everybody, but the scope is local. As in, okay, I'll just show you. The example is coming. Okay. After that, if you have a doubt, let me know. See, if traffic coming into R1 wants to go over adjacency 1, then the packet that is coming in needs to have a top label of 24,000. This example is clear, right?
One quick question. If some other router allocates the same label, so when you push that label onto the packet, won't it create an ambiguity there?
No. So the top label 24,001, it's coming to R1, right? So 24,000 has a meaning to R1. Okay. Let me talk.
R5 also has a 24,000 label for some of it.
So then the packet should come with top label of 24,000 to R5. Then it.
Okay. The label is popped and then the inside label.
Exactly. So the label has a local meaning only. So if looking at the last diagram here, right? If traffic comes with a top label of 24,001 to R1, that means go out of link 2. If a packet comes with the same top label of 24,001 to R1, to R2, sorry, it has a different meaning. Go out of top link, right? It's local. That's why it's local. The meaning is local.
But question is, do we really advertise? Let's say R1 is getting traffic from somewhere. We don't know what in this picture. But yes, how does that guy know that he has to send it with top level of 24,000?
So that's where segment routing traffic engineering comes in. So whoever is sending that traffic, right? He has a complete it has a complete topology, including all the adjacency seeds and node seeds. So it knows that if I want to send traffic, the path that I want my packet to take is to go over top link between R1 to R2. So send it to R1. And when the packet is going to R1, ensure that the top label is 24,000. We will see that example is coming. How exactly end-to-end traffic flow happens.
In the pure segment routing concept, are we not putting any labels? Is it only for SRT that will put?
No, SRT ends up using these labels. There are no other labels generated. There is a node seed, adjacency seed. That's all. SRT will end up using those labels to see. Once you have a label for a node and a label for a link, you can play with the path, right? For every node and every link in your network, you have a label and you know the labels. And you want traffic to take some path, you exactly know what labels to put, correct? That's what SRT does. So SRT doesn't use any special labels.
Yeah, I understood that. I'm asking in a pure segment routing, not using SRT.
Okay.
Can we still power packets, and if we can, are they going to use any?
Yeah. So if I want to send packets from, okay, I'll come to that, okay. That happens. We end up using labels. I'll show you.
So Pramod, one thing, this, why would this top label 24,000, would it not also need node label?
Yeah, that's.
Yeah, so it needs a node label to reach R1.
No,
Okay.
Can be also node. Will there be a differentiation?
Yeah, I think I'll go to that example. I'll go to that example first, and then come back here. Okay, let's look at this. Okay, this example. So traffic is coming into. Okay, so how traffic reaches R1 is somebody has to put the top label as 16,001. Say there's a R0 before R1. Somebody sent traffic to R0 with top label as 16,001. So 16,001 means send it to R1. 16,001 here is a node SID. Okay, I think let me finish this example. After that, if you have doubts, please let me know. Okay. So the goal is to reach R4 somehow. Okay. The best path to reach R4 is R1 to R4. So if I put the top label as 16,004, yeah, sorry. Okay, I think before that, say I want to reach R4. My goal is to send packet to R4. R4 has a node SID of 16,004, and node SIDs have a global meaning. So anywhere in the network, if my top label is 16,004, everybody knows that I have to send it to R4. So that's how the traffic reaches R4 in the first place.
No, but if you send via the adjacent SID, right? That adjacency would be to the neighboring router.
Yeah, so adjacency
come to R4 only, right?
No. So okay. Okay.
I think the node label is already popped out by the previous.
Yes, it is popped out.
It is popped out by the previous guys because now he's anyway knows he has to send out on this. So that's why you don't see that when it comes to end up in that R1. Okay.
Yes, that's right. Say for example, here the goal is to reach R6, and I don't care what link it takes.
From where to R1?
Yeah, R1 to R6,
okay.
or anywhere to R6. In that case, if my packet comes into R1, it just needs to have a label of 16,006, which is R6's node SID.
Okay.
So I mean, we haven't looked at node SIDs yet, but I'm just. Yeah. So node SID is global in nature. So 16,006, everybody in the network knows here that 16,006 is R6's label. Okay, because it's global. If packet comes anywhere into the network with top label as 16,006 means go to R6. It's a global scope. It's not adjacency SID. Adjacency SID is local, means only a link. But this node SID represents a node. Node is global. Anywhere in the network, it's unique.
See, if it's a top label, it will always be stripped, right?
No, need not be. Need not be stripped.
The adjacency label is the one which takes you hop by hop till the last node.
The reason adjacency SID needs to be stripped is, okay, going back to the adjacency SID example.
You can do one thing.
Yeah, one.
Complete forwarding.
Yeah, I think so. I want to get there.
Yeah, probably you can go here.
Sure. I mean, so you had a question, right? Adjacency SID is popped off. Hey, look at the last diagram out of the 4. Traffic comes in with, say, top label of 24,001 to R1, which means 24,001 top label means go out of adjacency 2. 24,001 label is for link 2. On the last diagram, the 4th diagram.
Top label is 24,000.
Yeah, here.
Okay.
Consider on the 4th diagram here. Traffic comes in with top label 24,001. The reason it needs to be stripped off is, if I don't strip it off, what happens? I send it to this guy. I send the packet to R2 with top label 24,001. Then what R2 will do? R2 will send it back. Because for R2, 24,000 means go here. So that's the reason, if it's an adjacency SID label and it's directly connected, right? So when do we pop labels? When it's a directly connected network to me. LDP or whatever, right? So the label concepts don't change. Label forwarding concepts don't change, whether it's SR or LDP. Point is, 24,001 is directly connected to me. Correct? So if I get a packet with 24,001, or which means it's local to me, it's my adjacency set, I will remove the label because it's directly connected to me. Popped.
No, I got that point. Maybe you can go with your flow. My question was.
Should that be 24,001 or should that be 24,002?
No, so I want traffic coming into R1 to take link 2, adjacency 2. That
Okay.
would be 24,001, right?
Okay, got it. So you want to, so you are now taking the next hop through one of your available link, which is
Yes.
dictated to be 24,001. Okay.
Correct. And the reason it's popped is it's directly connected to me. That's the standard label operation.
Okay.
Yeah. I mean, so any further questions here? I mean, so if traffic comes good, right, so far?
Yeah.
Okay. Now sorry, anything on the WebEx? Okay, we'll move on. So, coming to prefix SID or node SID, let me talk about node SID here because as I said, for normal prefixes, we don't allocate labels. We allocate label only to the loopback of the router, and that represents the node itself. Node SIDs are global, so they come from the global range. So if you look at this, right, 16,000 to 23,999 is preserved for the global range in segment routing. So,
Not coming yet.
I think okay, some delay. So 16,000 to 23,999 is reserved for the global range of segment routing, and global range means it's global. It has a meaning throughout the network, and node SIDs take the global range because they represent a node, and each node is unique in the network. Okay, so in this case, yeah, I mean, so ignore the first diagram. Please concentrate on the second diagram. Second diagram, the loopback 1111/32. To that, I give a segment ID number. It's a number basically. Okay, so the number can be anywhere depending on your range. So the default range is 8,000, 16,000 to 23,999. This 8,000 labels is my range. So I can give my segment identifier anywhere between 1 to 8,000. If you can manually change the range, you can manually change, I mean, all these are manually configurable. If you end up giving 10,000 labels as the range, then you can have you have 10,000 numbers to give as segment ID. That's the point. Simple thing. So here what I say is, again, IPv4 and IPv6 get separate IDs. Okay, so that's one thing to remember. So IPv4 I've given 1, IPv6 I've given 101. That means my label is 16,001. Actually, add 16,001 for IPv4, 16,101 for IPv6. It's still not common. Oh, it's there. Oh, I'm just so far so good. Yeah.
Is there any error we will get
Yeah, we'll get to know.
from our IDP?
Yes. So in ISIS or OSPF, if you configure this same router IDs, you get an error. Similarly, here you will get an error. You will get an error.
So you cannot have a same node SID for V4 and V6, even though it's the same loopback on the same router. Right?
So it's the same loopback, but the problem is, see, it's topology based, right? So the point is, I can take any path in my topo. IPv4 I can have a separate topo. IPv6 is a separate topo.
But it allows the config on some version.
The same thing, is it? Oh, okay. Okay. Yeah, maybe it will allow, but I guess that's not
Not the correct way.
not the correct way, because see, in OSPF by default it's just OSPF anyway you have OSPF v2 and OSPF v3 separate protocols itself for v4 v6. But when it comes to ISIS, right, you have separate topologies. You have multi-topo. So per topo assign one SID. That's a best practice. Okay, binding SID, as I said, it's about pushing traffic into a TE policy. If you want any traffic coming, you have a traffic engineering tunnel built, SRTE built, and you want traffic to take that that traffic needs to come with the top label of the binding state. For example, if you see the diagram, the green path is my SRT built, and I want incoming traffic to take that SRT, and my binding state for the tunnel is 64,000. So that means the traffic needs to come with top label of 64,000. Then it will take this tunnel and go out.
Just to identify which path, that is the
Yeah.
that is the reason for that binding set.
Yes, so it identifies the path or the tunnel. The tunnel is the path here, identifies the path. If I have 1,000 different tunnels, each tunnel gets a different binding set. So you can choose how to
So
go.
for example, this binding state, right, this goes over 1, 2, 3, 4, 5 routers.
Right?
So this binding state will be attached to each and every hop.
No, not like that. So, okay, the SRT path itself will have its label stack. The SRT path will have its labels to go through the 5 routers using the node SID, adjacency SID. It will build its label stack. Okay, but for traffic coming in, how do I decide that it has to take this tunnel?
The head end will know it has to go at 64 kb. So it's a TE path. I know that.
Yeah. So.
And after that, how we select?
So it will pop the 64,000.
Okay.
It will remove that label.
So that then next one will be adjacency.
Okay, so then it will remove 64,000 and put the label stack of the SRT path. The SRT will contain node SIDs and adjacency SIDs. Go ahead.
It's a collection of, this is
Yeah,
equal to a collection of labels.
correct.
Kind of
We want
alias.
to land which tunnel.
Yes.
There is no TE label as such. That's a binding state, like we have an RSVP TE, right? There is no TE label.
So RSVP doesn't have a binding SID, right? Or does it?
An SR I'm asking. So there is no specific, they are going to use adjacency SID and node ID.
No, node SID. So in case of RSVP, you have separate labels. LDP has assigned some label. RSVP will end up assigning different set of labels, right? Here, there's no change. You use the same node SID, same adjacency SID. Just play with it.
We have to statically configure on the head end. Like
Binding SID is dynamically a binding SID is allocated. The moment you configure a TE tunnel, binding SID is given by default. But say you can change it manually. In this case, I've given it manually. Sorry, there's a question on the WebEx.
Yes, I was asking this, I think the question is, and not clear to me yet, is how the packet is steered through the intermediate node when
Okay.
I know I want to use a binding 660. So I know there's a tunnel from one on the left to the right, but
Okay.
how is it steered through the rest of the node?
Okay.
I know it's alias or it's a set of segments in between. So there are a set of segments IDs in between. So is it really tunneled, all of them, and then we have a binding SID on top of that, which takes to the entire network, or how it is?
Okay. Okay, here we have 5 routers in the TE path, right?
Right.
Let's call them R1, R2, R3, R4, R5, going from left to right.
Right.
Okay, so R1, R1 to R2 I have an adjacency SID. Similarly, R2 to R3, R3 to R4, R4 to R5. So I have 4 adjacency SID because 4 links, right?
Right.
So my TE tunnel can have 4 labels. As in a 4 label stack represents my TE tunnel, for example.
Right.
Got it, right? So my SRT tunnel is built with 4 label stack. That's already there on the router. And if a packet has to come into the router and it needs to take these 4 label stack, as in this SRT path, then how to do that? So what I do is I give label 64,000 as a label for my path, as in it's a representation, that's it. It's a name for my path.
So it's not carried through the network.
No, it's not carried. It's not carried.
It is the guy on the left knows about that. Once it ends up here with the label 64,000, you
Yes.
know what are the intermediate.
Okay, so the diagram may be a bit confusing because on top also I mentioned 64,000. That was just, I should have given maybe more white space.
So
It's
it's
just
not
like a diagram header, that's it.
Ideally, the head node will be mapping to the
Yeah.
label stack, which
Correct.
will map to 4 adjacent IDs.
Exactly. So 64,000 will be removed and the 4 labels will be pushed and then it goes.
So that
Okay.
then we have a state of which tunnel, which label.
Yeah, it will maintain all that.
Only the head end.
Only the head end. So that's awesome. Right? RSVP, everybody has to maintain state. In case of SRT, only the head end needs to maintain state. Nobody else knows that there's a TE going on.
So
At each point, just follow the normal label forwarding thing. If it's directly connected to me, pop it out. If it is not directly connected, it's a remote node, then let the label be, let it
Keep the label, right?
keep the label and forward.
So everywhere adjacency ID is the one playing the key role switching from.
Depends actually. See the reason, okay, the reason I've
Only
used,
doubt I had is,
Sure.
only thing where node SID plays a
where node SID will come into picture, where adjacency SID will come into picture, right? For the forwarding, I'll come to that.
See, one question is that adjacency SID is exchange modules between the directly connected.
No. So, not like, okay, so the way link state protocols work is, within their area, the area may have 100 routers, but each area creates information describing its link and the prefixes it's connected to. That's how OSPF or ISIS basically work. The link they have, the link meaning they say I'm connected to this router and these are the prefixes I have. And this information is flooded to everybody, to all the 100 routers. So all the 100 routers know all the details about each other. So in this case, say R5, assuming the rightmost is R5 and the leftmost is R1, R5 knows all the links of R1. Similarly, R1 knows all the links of R5 and all the details about R5. It's like a map. Everybody has the entire detailed map of the network. That's how link state protocols work. So along with the map, which is a link and prefix, you're advertising adjacency SID and node SID. So everybody knows about everybody else's node SID and adjacency SID. It's just not directly throughout.
Adjacency SID is advertised?
Yes. It's part of the OSPF advertisement.
Okay.
Just that it has
Okay,
the meaning is local. If I get with my adjacency SID, I know what to do.
Yeah, everybody on the node, different nodes can use the same number, but it has
Yes.
only local significance.
Yes.
The one on the left who sends with the top level 64,000,
Yeah.
what is the mechanism you use to advertise that to that guy? And is it advertised by this R5 to the R1 and or
No.
how is it?
So R5 does not even know that there is a tunnel going on. So only the head end knows about the tunnel. R5 does not even know that he's part of the tunnel.
Okay, got it. Okay.
Yeah.
I think the stack can get really huge.
It can get huge.
There's a big network.
Yes.
Routers can only support like 4 or
So current label stack in DNX, I know about DNX at least, current limitation theoretical max is 6 in one pass. But now in the latest release, they have made it 12 or 11 actually. So the last label is a recirculation label. So the ASIC will recirculate back and push some more labels. So currently the label stack allowed is 11. 701, 126i, you can have 11 labels pushed.
So after every 12 hop, I have to research it.
So currently, actually, Broadcom, one pass, only 6 labels max. Now if I have to push more than 6, I have to recirculate back and end up pushing some more. So it's already recirculation, which means their throughput will reduce by 50%. If you have to push more than the ASIC capability.
Okay. So the Broadcom is 6 pass. What about our Cisco ASICs, do you know?
9K, I'm not too sure what is the math.
15, I think.
15 in one pass, huh? Yes. Wow, okay, that's awesome.
15.
Maybe I saw something.
No, 15 maybe with recirculation. Is it with recirculation or without recirculation?
Detail I don't know. Somewhere I saw that it is 15. And
Maybe with,
Wow.
because 15 in one pass, I don't know. Tough, yeah. That's what I think.
Okay.
So why is it not adjacency stated? Why are we advertising to everyone? Anyway, it is having local importance.
No, it's local importance, but from somewhere else, I want to decide that I want to take this link. Sitting on R1, I want to decide that on R5, this particular link I want to send traffic. So R1 needs to know about R5's adjacency SIDs, right? Because all this action is taken on the head end only. If it's SRT, only the head end knows about it. So it means head end needs to know some other remote router's adjacencies also.
so you will end up using more node SIDs to reduce the label stack, right?
Yeah, if you, okay, so
Instead of segment.
when you use adjacency SID when you don't have, the best path is not through that. See, if you use a node SID, if you're okay to reach that remote node using the best path, just one label is enough. But you don't want to use the best path. You need to take a non-best path. How do you do it? Then you start using adjacency. You got that point, right? You asked, right, when to use adjacency, when to use node SID. If my remote router, wherever I want to reach, I'm okay to use the best IGP path. best cost path, I can directly use a node SID. Getting right? But if I want to use a non-optimal path, then I want to use a different path which is different from my best cost. In that case, I can't use directly the node SID, because the moment I send traffic out with node SID, it's going to take the best path to reach. If I want to take a non-best path, then I have to start giving adjacency SIDs, because then I have to say, go through this link, then this link. That's when I start need to use adjacency. If I'm okay to use best path, directly put node SID. No need of adjacency SID.
So general SR, if you are not diverting anything apart from
the best cost,
it's always only node SID.
Only node SID. No need of adjacency SID.
Okay.
So I don't need to put the full entire segment.
The T replacement would be where adjacency SID trace.
Correct. In the SRT, I want to use some path that I like, which is not the best path.
Anything with respect to engineering the traffic, that's where
adjacency SID is exactly. That and TILSA, loop free alternate, which we'll do next week. That also needs to use adjacency. Yes. Yeah. Yeah. No, you don't need. You need to do SRT only if you want to take the non-best path.
So, can you take one to four?
Okay. Okay.
Talking about any SRT and tell us when we use it and we use the
Okay, see, if I don't want to do SRT, then I don't need to use adjacency SID.
Yeah.
Yeah, I'll show that example.
No. So what he's asking is, whatever you had in the next slide, right? One end-to-end path.
Sure.
Where normally with SR, without SR, how it will be? That difference, if we can explain, people will be.
Sure.
Yeah, Krishna,
Yeah.
one clarification, Krishna. So in this topology, if the packet comes with all the four adjacency SID label stack, not the top level is 64,000.
Okay.
It will still take the same T eternal, right?
Yeah, it will still take the same path. Yes.
Okay, and the incoming, and if the incoming packet comes with the node SID of R5 and all the below labels as the four adjacency SID labels. So till the R5, the normal best path forwarding will happen, and from R5 onwards, this adjacency SID lookup will happen. If it is applicable for that, it will forward, or else it will drop, or?
No. So I want to sense R5 is the rightmost outer assuming, right?
Yeah.
And leftmost is R1. My best path is R1, so let the middle be R3. R1, R3, R5. That's my best path, right?
Yeah.
So if my top label is 16,005, which is R5's node SID, then R1 will retain the label 16,005, send it to R3.
Yep, all the five labels will be retained till R5.
No, I don't need five labels. I don't need five labels, right?
What I was asking is the four adjacency SID labels, you already have the stack. Let's say the top label is R5's node SID label. In that case, the packet from R1 to R5 will be forwarded with all the five labels, and before R5, the node SID label will be popped out. Then R5 will look into the next adjacency label
on stack and forward accordingly. Correct.
If it is not available locally on the R5, it will be drop or?
It will be drop. I mean, so for R5, it's just getting a packet with some label, right? It sees the label. It doesn't know what to do with the label. It will drop it. That's the way.
Yeah.
So important to remember that label forwarding, nothing changes. The concepts are the same. Whether it's LDP, SR, nothing. Penultimate hop popping, dropping the packet if you don't know what to do with the label, all that remains the same.
Got it, Krishna. Yeah, thank you.
Ram, are you assuming that there are routers beyond this R5?
Yeah, Dakshish, I'm assuming that.
Okay.
Yeah.
So at the beginning, I said SR replaces LDP traffic engineering. What is the third one?
The third one is RLSA. So it replaces RLSA.
Okay. So LDP replaces by node SID.
Node SID, RSVPT, you can say by adjacency. It's a crude, but you can take it that. Okay. You can take it. Okay. Regarding the, tell me.
So if we have more than 11 intermediates on the SRT, so it has to be recycled on the 11th.
Okay, so that's the thing. Through those 11 routers, right? Are you okay to take the best path?
No, we are doing SRT.
SRT. So out of the 11 routers, do you really want to specify all the 11 link exactly?
Yeah.
Or are you okay to specify 3 links? Okay, see, let me get to this example, okay. You need not have 11 labels. Okay, yeah, okay. Coming back to this, right? Your point is to take, you need, the best path is this guy, right? R1, R4, R6 is your best path, but you want traffic to go from R1 to R8 and then from R8 let it go to R6. Okay. Now in this case, I just need to add one extra adjacency series to go to R8. From R8 it can take the best path and go to R6. 2 labels enough.
Suppose there is a requirement for more than 11 labels, then if the cache will be...
More than 11 labels, it will drop it. The ASIC cannot handle. Currently, ASIC cannot handle more than 6. 6 is pure SR. The moment you add services and other things, right, that reduces.
So the recycle works only if it is not an SRT traffic, a normal one, where the intermediate can have some information on.
Yeah, so if from the intermediate router you're okay to take best path, then you don't need to specify these adjacency fields anyway. That's the node field is enough, because from here, from R8 you're okay to take the best path. On R8 you just need to give, I mean, you need to ensure that the top label goes out with 16,006. R8 knows that my best path to 16,006 is R8 to R4, R4 to R6. So 2 labels are enough in this case. Even though I'm actually taking how many links? 3 links, 2 labels are sufficient, because my requirement is just to ensure that it goes on this link. After this, it can take the best path. Right. Hey Venkat, to your thing, shall we do it now, the services?
Yeah, that would be better in next time, like how the traffic is originating from R1 to R6, so what are
okay,
things will be imposed will be better.
Okay, see, if you are looking at pure LDP point of view, where LDP allocates label for the loopback, so services are always loopback to loopback, right? So with SR and LDP, nothing changes. There's no difference now. LDP has allocated a loopback label. SR also has allocated a loopback label, which is a node field. That's it. Nothing changes there. But now your service traffic, you want it to start taking this path, etc. That's when you have to do services over SRTE now. Services over SR, there's no change. No change as in it's very similar to LDP. LDP allocates a loopback label. SR will allocate a loopback label.
So on the SR part alone, not SRT. So we need to use the loopback of R6, and we have allocated label for it.
Correct.
So from R1, we put that label on the packet. In fact, that label gets stripped out, right?
It will get stripped out by R4, because R4 will do penultimate hop popping.
Okay.
The same with LDP also, right? R4 will strip the label, and if there's no label below it, it goes as plain IP packet to R6.
Almost outer in between R4 and R6.
Okay, say this path. I mean,
so when the packet goes out of R4, does it have any label?
it will have 16,006 again.
That label now there is everything separate.
Okay, L2, L3 we can.
Can you just tell us like what would be the label stack there?
Okay, fine. Fine. So you have L3 VPN between R1 and R6, and within the core you are taking the best path. Okay. If you are going to use best path, nothing changes from forwarding perspective between LDP or SR. Okay. But coming to label stack, you will have a service label for your prefix or whatever L3 VPN. You will have a service label that will be a bottom label. Top label is to reach R6, which will be 16,006. The only difference between LDP and SR is LDP hop by hop the label keeps changing.
So now when R1 is sending the traffic, all it does is only push the 2 labels, which is
That's all.
the service label that you use it.
Then one label to reach remote loopback. That's all. It's a 2 label stack. LDP also services is a 2 label stack. Here also the services is a 2 label stack.
So when R1 sends with 16,006, how does it know it has to go to R4?
Okay, so the best path. Okay. R6 advertises a loopback, right? Correct. Right. So the loopback, this guy knows. So he will build the best forwarding path for the loopback. Okay. And associated with the loopback, you have a label, which is a node set.
Okay, so node set won't be R4 set at the top. It will be
No. It will be R6 because R1 knows that if with 16,006 is sent to R4, R4 will send it to R6.
So basically it is retaining that 60,006 all along the path.
Yes.
Except the penultimate hop.
Exactly. Exactly.
No, but where is the label coming into picture, right? Because usually there is, if you have adjacency set, you have a switching at each hop.
Correct.
Now, if there is no adjacency set,
Because I'm okay to go the best part.
only the node set.
Only
How will R4 switch? What
Okay.
will be the
R4 also knows that that my path to go to node 16,006 just represents
no
R6.
label at all here.
There will be a label. I think R1 will send with 16,006.
Correct. What I'm saying is 16,006. Outgoing it is going, right?
Correct.
That is coming to R4.
Correct.
R4 also incoming is 16,006 for it.
16,006 for it. Correct.
But
It doesn't do any pop or anything, right?
It will pop.
If you don't have that link,
If you don't have, if R4 and R6 are not directly connected, R4 will get 16,006. It will swap it with 16,006 again.
Okay. So it's like routing only. R4 is just like plain routing.
Plain routing. So segment routing uses, so that's why, right? So initially, we had two extremes. One is just pure destination based. The other extreme was pure source based. Segment routing is a mix of two words. Wherever you want to take the path you want, use source based. Wherever you're okay to go with the best path, directly use destination forwarding. So it's the best of both worlds.
so the same business swap happens.
So it will swap to the same label. Okay, that's the other.
Also, this is value is the mechanism we use to announce if your application is
Okay, that you have to use controllers and all that. Those things are in place. So I mean, some things are those things are in place.
So you need API for escalation, communicate the controller to get the entire.
So currently the way we do it is, it's still primitive. I mean, see, segment routing is still evolving. It's not very old, right? So currently the way we do it is there's a central controller somewhere. You tell the controller your constraints or the path you want to take, etc. Through constraints. Through API, there's a PCEP protocol, Path Computation Element Protocol, whatever. We'll get to that later. The point is, there's a controller. Controller will tell this guy, use this label stack. If traffic coming from somewhere, for that, use this particular label stack.
The application will request for those.
The application will have to tell controller that this is what I want, this is the path I want, these are the characteristics of the path I want. This guy will accordingly give the labels.
Yeah, so Krishna?
Yeah.
Yeah, so Krishna, can you please go to the SRT topology? I have a question there.
So I don't have SRT SRT topology. Okay.
Yeah, the previous one.
Shall we move on with the slides? I mean, as and when we come there, can you ask your question? I think that will be better. Is that okay, Ram?
Okay, sure, yeah.
Yeah.
And one question regarding the PHP.
Okay.
So in segment routing also we support the explicit null labeling, right?
Yes, we do. That config I'm coming to. We support.
Okay, sure. Yeah, I will. Thanks.
We support it. Explicit null is there.
Okay. Yeah.
Okay. Yeah. So Venkat, okay, right? There's no difference if you're willing to take the best part. The same thing. Complete control over forwarding path. Again, yeah. So no need of LDP, no need of RSVPT. I mean, SR itself can take care of everything. Scalability is very high because you don't maintain any state in the core. Only the head end needs that. So SR runs natively on MPLS or IPv6. IPv6 is SRv6. It's just still being developed. It's very new. But SRv6 is there. We'll do SRv6 later whenever it comes. It can coexist with LDP. We'll again come to that. You can have SR and LDP running together. LDP has its own labels, SR has its own labels. So as I told you, right, for prefixes, SR doesn't assign labels. LDP does. So you can run LDP and use, I mean, there's no need for it. If you're running a service provider network with services, right, you actually don't need labels for the links. What is the point of it? Unless you want to do RLFA and all that. But that TLFA takes care. So technically, in a service provider network, multiple services, you don't need labels for your links. by default LDP is preferred, but you can make SR, you can configure SR to be preferred. The reason they made LDP preferred is to allow for migration, smooth migration. So you already have LDP running on your network. You introduce the SR config. LDP will still keep running. Whenever you're ready to make the switch, switch it. We'll anyway come there.
There will be a scalability issue, right, in case of migration, because the LDP will also allocate labels. SR will also.
SR, how many labels does it allocate? No, it's not too much. SR allocate, how many links will you have in your network? 1,000 links? 10,000 links? How many nodes will you have in your network? 1,000 nodes? So how many? 11,000 labels. Now you may have 1 million prefixes, but SR has ended up allocating only 11,000 labels.
So going forward, right, we can eliminate SR to have prefix for prefix links to have levels of prefixes also, right? We can configure like that.
You have a, you have a prefix map. You can map manually that for this prefix have this label. That you can do manually. You can, but there's no point. I mean, what's the use of it? That option is there. You can do it.
If you have LDP and SR operating.
No, LDP takes precedence. Say, I have a loopback, right? LDP has allocated a label for the loopback. SR has also allocated a label for the loopback, right? And there'll be different labels. They won't be the same, correct? In that case, LDP takes preference. For SR to take preference, you have to manually configure SR to take preference. That config is there. I'm coming to that config. Yeah. Okay, so complete control over path. So this is what I wanted to say, that you can use a combination of node SIDs and adjacency SIDs to take whatever path you like. But I think we've gone over this quite a bit, right? So I'll move on. Yeah.
Just one question on that one. So
sure.
Who takes that? We can program that path, which we can, for everything we can program it. No? We can configuration.
Yeah, we can manually configure the SRT path. We can say take this, or we can let a controller do it.
So mostly in real time, it's controller.
Controller is scalable. Massive network manually, yeah, stuff. So for each link and everything, right, you will configure multiple constraints or characteristics and all that, and you will. So the controller knows all the links and all the characteristics of the links. You tell the controller that this is the characteristic I want for my application. Controller will accordingly calculate the label stack and give it to the head end.
I can check it before we can do that all day.
Yeah. On the.
If I want to do the changes, I can tell the controller, oh no, I don't want this particular adjacency. Can you change it? And we can do that.
You can do that. In that case, you have to manually specify it, and you can manually do it.
We can do that.
Yeah.
Without controller, it's as good as the explicit path.
Yeah. No, it's not explicit. I mean, this can dynamically also calculate. The head end can also dynamically calculate, but that becomes like RSVPT. On RSVPT, what happens? It's the head end which calculates the path. So SRT can do the same. Head end router can also calculate. It can. So again, the same attributes that you give it to the controller. You have color, and now we have. Without attributes, it will end up finding the best path only. See, if you don't give any constraint. Correct? Okay. You can explicitly mention, or you can give, say, a color to each link. Say you've given red and blue color to all links except for one. One link only has red color, it doesn't have blue color. And you want traffic, or say you have red and blue everywhere. Just one link, you have red everywhere. Just one link you have red and blue. Assume. Okay, in a network, all the links are red. Just one link is red and blue. And you tell the head end, you define a constraint that I want to take the blue path or blue link. Blue link has to be hit. Then this guy will automatically calculate that I need to reach the blue link. And that's possible. Head end can also do it. But then that's not very different from RSVPT. The moment you introduce a controller is when it becomes SDN, right?
But also the state need not be maintained in the network.
In the core, there's no need of state.
That is one advantage.
That's like a big one. So in the core, the core devices can be dumb with a lot of forwarding capacity, but otherwise can be dumb. Right? Only your edges need to be intelligent and all.
So this controller needs to have the entire database, right? I mean,
It needs to have, yes.
Which are behind each router and all, right?
It needs
so
to
how
have.
does it get this information?
Using BGP, you have a link state LS, BGP LS. We will get to that later anyway, introductory. So this way we have, I can skip this, I guess we discussed, right, how to, on the WebEx, any questions so far? Or anything? Hey guys, the thing is, I sit in the bullpen opposite to Tia's cabin. Few of us work on SR every day, so if you have any doubts, feel free to come, because I saw a comment that all the people clarifying doubts have taken over. But if you have any fundamental questions, you can always come to the bullpen opposite Tia's cabin. Few of us sitting there, we know SR. I mean, if I'm not there, we have Saravnan or Magan, or now even Aniket knows Liquid, so you can actually come and ask questions. Doesn't matter.
And guys, feel free. That's the idea.
Yeah.
As much as discussion we want to do, let's do it. It's a 4-session series. We can extend based on like.
We can extend. I'm ready to do this again, but.
So don't worry that one topic will not be covered, or we will strip off something. That will not happen. So for him, as many as questions, so that is good. So we'll understand more.
Yeah, sure. Feel free. Okay, we'll move on then. No? I guess.
One question. So that 1603, right? That's a node ID.
That's a node ID.
So, but how that R2 knows how it differentiates an adjacency or the node six?
So that's.
So first look at the adjacency. It's not matching in its database. It's go to the node six.
Not like that. Not like that. See, this label stack is there because this is the path I want to do.
Yes, that's.
I could have directly given 16,003 and have gone to 16,000.
So my question is, it has 16003 as my adjacency also.
No, it can't be. It can't happen. It can't happen. Because 16,000 is sRGB. It's a global block.
Okay, we have a different.
We have separated there, yeah.
So my question is, how a router, when I get a label stack, it knows whether it's an adjacency or my node set. How it differentiates that part.
Okay, so say traffic has come in with top level 24,000, right?
First thing is, from this diagram, I can take an adjacency.
No. So this guy will look up. We'll see what is 24,000. First of all, it's not in the sRGB. So it's, but in any case, he'll look up what is 24,000. For him, in the MPLS forwarding table, it is 24,000 is go over that.
Vijay, to your question, I will which
Based on the block range. So
16,000 to 23 is different. That's the one.
Okay, so now we'll come to the configuration part. ISIS, I have ISIS and OSPF config. So under ISIS, you have segment routing MPLS, and then if you have LDP also, then give SR prefer. Similarly for IPv6, and you need to allocate node SID to a loopback, right? This is how we do it. Prefix SID index. You either give an index, it will add this index to your sRGB starting range, or you can give the absolute label. You want to specify explicit null, you can specify explicit null. Now this N flag clear, there's something called Anycast SID. I won't go into it today, but if you want to use Anycast, then you can do N flag clear. We'll do it later. Yeah. Yeah, I mean, anyway, I'll share this slide for the config. Basic ISIS show commands to check node SID adjacency SID is this. You do show ISIS adjacency details. You will see the adjacency SID. And then you want to see the node SIDs, do show ISIS segment routing label table. It will tell you all the node SIDs it nodes of the entire topo, not just itself. So in this case, V4 adjacency is separate because there are two different topos for me. ISIS in XR by default is multi-topology. Since IPv4 is separate topo, IPv6 is separate topo. Per topo it will generate. And then if you want to exactly know how ISIS is sending these adjacency SID nodes, these are the details, TLV numbers, which TLV, what goes. I don't want to concentrate too much on this. This is just pure data. I'll share this data will be there, or you can go through RFCs or whatever. And this is the packet capture I took. In the packet capture, it shows that so this node SID bit is set, and this is my SID index, which is 1 here. Okay. And then under the router capability, is it segment routing capable for V4, V6? What is my starting of the label range, 16,000? And then it also shows the range. It will show 8,000 somewhere. Okay, I have not mentioned it. It also tells me the range.
And Krishna,
then for
Krishna,
yeah, sure, tell me.
yeah, Krishna, this explicit null is applicable only for the node SID or
Correct.
okay.
Correct.
Yeah. Thanks. Yeah.
And for the way adjacency set goes is under this extended IS reachability TLV. I mean, these TLVs are there. And to check, I mean, you can't do packet capture always, right? So the ISIS database verbose, give the LSP ID verbose. Under that you will see prefix SID index, n-bit set. Then you see the sRGB base is 16,000, range is 8,000. And to get the adjacency SID, you go on. You see the adjacency SID. Coming to OSPF, OSPF config is you enable segment routing MPLS under OSPF and under the area also. Some areas you don't want to run segment routing, you need not mention it. SR prefer again, explicit null, N flag, I mean, which is for any cast SID. You can give the index under the loopback or you can give the absolute label value, all that config is there. OSPF show commands again. Show OSPF segment routing adjacency SIDs. Will show you the adjacency SIDs. And then, sorry, it will give you, it gives an adjacency SIDs. Node SID, there is no command particularly, currently. Okay, another thing to note is, most of the service providers run ISIs. So segment routing development for ISIs is far ahead than segment routing development for OSPF. I mean, eventually OSPF is catching up, but it's always a few releases behind ISIs for segment routing. So if you want to do the latest and greatest, always use ISIs. OSPF neighbor detail will again give you the adjacency SID per name. Again, OSPF LSA types, a lot of data. I'll skip this, you can always read it. OSPF LSA, this is a packet capture I did. So, one main point is opaque LSA type 10. That's a area-wide opaque LSA. So we have three opaque LSAs, I think 9, 10, 11 or 8, 9, 10. One is link local, one is area local, one is domain local. So segment routing is area local, opaque LSA type 10, and then under that multiple TLVs are defined to transmit all this info. Again, you can always go through this. These are the captures. All the data is there. I'm skipping this again for your reference. Okay, to check the OSPF database, the command is show OSPF database opaque area. This is the TLV type. Each TLV type has different info, and that's mentioned here. That the router ID is in type 1, type 4 LSA, I mean LSA type 4 within opaque area, TLV 1 has router capability, blah, blah, blah. So you can accordingly run the command. Show OSPF database opaque area 1, and then I guess here it is show OSPF opaque area 4. You can go through this. Coming to the forwarding plane, I guess we'll go through the forwarding plane part. Segment is label, segment list is label stack. Again, we have done this. I'll quickly, explicit null can be enabled if needed. Yeah, the node imposes a prefix SID if the destination matches, I mean, if the destination is your loopback, then put the node SID and send it. This is just fancy English. Downstream neighbor is SR enabled, blah, blah, blah. We have discussed this already. Node imposes adjacency SID if it needs to send packet over a particular adjacency, ideally when it is not part of the best path. If it's part of the best path, no need to put it. Directly put node SID. And then TILSA will
null not applicable for adjacency.
Sorry?
Like explicit null, why is it not applicable for adjacency?
No, because if I receive a packet with explicit null, which link am I going to send it out of? How do?
No, that is the last router, right? I mean, when I'm getting it, that is the last router. I am popping the and I'm sending the packet only.
Correct.
The last guy.
In that case, you can have it. So explicit null is never for an adjacency SID. It's for a node SID. So because adjacency SID represents a link. Your question you're saying is if my last label is adjacency SID itself. Then
right. Last label is adjacency SID.
So in that case, the last label should not be adjacency SID. It should be a node SID. So the way dynamically when it calculates it, see if you are manually specifying
Right.
then you can do whatever you like. But if dynamically it's calculating, the last SID always ends up being the node SID.
So if you are mentioning an explicit part, that's what I'm
Then you can mention an explicit null also. You can do it. See, if it's explicit, then you're mentioning the entire cycle. Then it doesn't matter.
So, but that is a default behavior, right?
Default behavior is not default behavior for.
Sorry, implicit null is a default behavior.
Correct. The reason you don't have explicit null for adjacency is it's not meant to represent a node or a prefix. I mean, the meaning is for something else, and explicit null. Your question is valid. Maybe you can open a 7.6. I don't know, but to me, I don't know if it makes sense to me.
We were talking about only two SIDs, right? One is the node SID and another one is the adjacency SID.
Correct.
The prefix SID, what is that?
So node SID is a special type of prefix SID. So node SID is nothing but a label to the loopback. Loopback is a /32 prefix generally, right? So node SID is nothing but a prefix SID. But if you have other prefixes which are not loopbacks, you can have 1,000 routes in your routing table, right? Then in that case, manually you can assign a label to them in SR. Then they become prefix SIDs. But node SID is nothing but a prefix SID. It's allocated to the loopback.
So if you are assigning a prefix SID like 1,000 routes, it's similar to a
LDP, yeah.
Right? You are defeating the purpose.
Defeating the purpose, yes. So the only place where I have seen that people are allocating labels to SR labels to prefixes is LDP to SR migration case. That's it. Once the migration is done, remove it. No need. Like that. So far so good, right?
Right.
So I had a lab built up. I don't know, you want me to go? Okay, so anyway, we'll go through the lab. R1, this is my topo. My source is R1, destination is R5. My best path is R1, R2, R5. But if I want to take a different path, I can go from R2 to R3, R3 to R5, etc. I mean, that's the reason I built a topo like this. And the numbering is 1, 1, 1, 1 for R1, 2, 2, 2, 2 for R2, the loopbacks. And 10, 0, 12, 1 for R1, 10, 0, 12, 2 is the link IPs. Link IPs are 10, 0, XY dot, whatever the router number is. XY is 2 routers. Assume that we need to send traffic to R5 from R1. R5 has node SID of 16,005. I'm getting that from the database, ISIS database. And if you want to check what is the node SID I have received from somebody else, you can directly check it from the database. Anyway, or the show MPLS forwarding commands, all of them will show the same thing. But if you want to see what IGP has given me, this is a command. Check the database. So it's saying my sRGB base is 16,000 and my index is 5, which means 16,005 is the node SID coming in from R5. I'm checking R5's database. When R5's LSP. Okay, on R1, so if I do show MPLS forwarding prefix, this is R5's loopback, it says 16,005. What I wanted to show. On R2, the best part to R5 is directly connected again. It will pop. Again, you want to take a screenshot of this, or you remember this topo? Fine, right? So show MPLS forwarding label 16,005 on R2. It's a pop label because it's directly connected. This is what it is. Pop. If R2 is directly connected interface to R5 goes down, then it will load balance. Okay, this is another good thing with SR. LDP doesn't load balance, right? I mean, your load balancing comes if the prefix is load balanced in the RIB. In the RIB, if you have two next hops, then you will have two different labels as well. LDP you will have two different labels, but you can load balance. In case of SR, it load balances again. Same label. Okay, so I mean it's not very different from LDP. I mean the only thing in LDP's case is your routing table shows you have two paths for a prefix, which means two neighbors. So both the neighbors, each of the neighbor would have allocated a different LDP label for the same prefix. So you'll have different LDP labels going out. In case of SR, because node seed is common, you'll have the same label going out. Fine, right? Any doubt?
It's per packet or
Per flow. I mean, that doesn't change. So whether it's LDP or SR, it's all per flow. That part doesn't change. So traffic coming in with 16,005, both R3 and R4, which is R3, R4 will pop it. I mean, the same thing I'm showing. Yeah, so this is how it is. 16,005, R3 will pop it, R4 will pop it. Same thing. If you configure explicit null for the node SID again, then show MPLS forwarding labels on R2, which is directly connected, it will swap it with the explicit null label, which is label 0. Explicit null is label 0. Yeah, that's about the forwarding. SR coexistence with LDP. So you can have LDP, RSVP, TE, SR, RLFA all running at the same time. The reason all of them can run at the same time is because each of them get labels from, the labels are unique. SR will pick from one range, LDP will get from something else. So all of them can coexist because the labels per protocol are unique. So when it gets programmed into the hardware, it's unique label. So that's what all this is about. LDP is preferred over SR, use SR preferred to have SR preferred. LDP and SR example I have both enabled. Same topo. So in case of, I mean, this is what, on R1 if you check LDP label for 5555, it uses 24020. For SR, it is 16,005. So I have LDP allocated a label, SR allocated a label. By default, since LDP is preferred, forwarding takes LDP. That's the point. R2 will just pop it as a standard forwarding thing. 24020 pop. If you configure SR prefer, then what happens is you do show MPLS forwarding prefix. It's not the LDP label, it's a SR label now because I preferred SR. That's it. So if you do LDP to SR migration, LDP and SR can coexist. LDP preferred by default. Gradually update software on all nodes to get SR feature. Then enable SR. Nothing changes from data plane because LDP is preferred. So forwarding, nothing has changed. Gradually prefer SR over LDP using SR prefer. So say you have 5 routers in your network. 2 of the routers you have upgraded to SR. You can actually switch to SR prefer on them. That is because even on the routers where SR is not preferred, I mean, no. You need to upgrade all to SR first, then SR prefer gradually. So you have 2 routers out of 5 which are SR preferred. The rest are LDP preferred. Still it will work because the routers which have LDP preferred, but they're getting a packet with the SR label on top, they will switch it accordingly and send it up. Part is fine, right? So for a packet coming in with SR label, forward using SR. Packet coming in with LDP, forward using LDP. That's why it doesn't break. You can have both, and you can slowly migrate SR to, LDP to SR. Data will be forwarded as per incoming label. This is the thing. This is the figure. If a packet comes in with 16,005, switch it out with 16,005. If a packet comes in with LDP label, which is say 9,001 in this case, switch it out with the LDP label of the next guy. So both work at the same time. Yeah, this is like this is the last slide, giving a comparison between SR and LDP. I mean, what are the advantages of SR? You just have IGP. You don't have IGP LDP sync problem. 100% FRR. In case of LDP, you can't get 100% FRR. SR, you get 100% FRR. If you're using RSVP, your core needs to maintain state. In case of SRT, core doesn't even know that there is T going on. And yeah, the rest you can. I'll go through it. We are done.
So apart from label stack, what is the other disadvantage?
Other advantage of SR?
No, I feel label stack will be a disadvantage because we need.
You need more labels. Yeah, that is one disadvantage.
What else we have?
That's why I can't think of any other disadvantage.
The constraint-based routing is there, like RSVP, right?
RSVP has constraint, SR also has constraint based. SRT.
So all the attributes in the RSVP are similar here, like link affinity.
You have more actually this time. So RSVP you have affinity bits, and then you have bandwidth, affinity bits and bandwidth, right? And SRLG. Those same features you have in SR also, but in SR with the latest thing you have performance measurement. You can actually real time measure the link delay.
Okay, and then it will calculate dynamically.
Yeah, dynamically.
But how does it do that? I mean, send a probe or something.
It sends a probe, and then so every 30 seconds is when the IGP will change. Otherwise, IGP, if it churns too much, right, it's a problem. You can configure that time limit. Every 1 minute, check the latency. Send that info to the controller. So controller can dynamically push new path if the latency has suddenly changed and all that. In case of RSVP, I don't think it's dynamic. I'm not sure. Maybe there are two.
RSVP, all links and bandwidth you have to tell the controller for all this. Yeah. That is, there is nothing.
IGP metric, TE metric.
There is nothing, no tool or nothing to dynamically calculate or something, right? We have to tell this is the link coloring, this is attribute.
That you manually configure, but performance measurement is dynamic.
Okay.
The delay, latency.
Okay. Oh, that
is dynamic.
Yeah.
Krishna, when you say SR is a hybrid based, right? Like when it will behave like source based.
Source based routing is you're giving the entire label stack to the headend. When a packet comes to the headend, you give it the entire label stack. That's source based. Now, because the headend decides how I should forward.
Yeah, so all the labels are decided there.
Yeah, I mean, so somebody tells the headend that uses label stack. So who's deciding the path in this case? It's the headend router deciding the path, right? In case of a normal thing, nobody decides the path. Whatever is my best path, I just choose that and go.
So will it play a major role when we have a packet has to steer across service provider, different service providers, which cannot be controlled like?
So you have something called BGP egress peer engineering. I mean, I didn't want to add too much complexity. So if you have two different BGP domains and you have 5 links between the two domains, for example, now BGP can allocate a label to that link again, to the inter-domain link. That's called egress peer engineering. So your label stack, the bottommost label, should be whatever BGP link you want to take out to the next guy. That is also possible. Which is not there. I mean, you have MED and those things you can do, but they're not very granular.
So what is the tool that you use to as a controller? No?
PC. That's configurable on XR. Now
one router will act as a controller.
Controller, yes. So most deployment
within the topology or like an RR kind of like.
You can have it within the top or you can have it somewhere sitting, depending on your design.
But generally the field, what is that?
Outside. It will be XRV 9K box. It will be some virtual box, XRV 9K, and that will.
Okay, thanks a lot, Krishna. And
Krishna, you will be sending the slides?
Yes, I will send the slides.
So we will be maintaining the slides recording on a common page. I'll be sharing those details. I'm working on those. And there are, I think, 3 more sessions which are already planned one. But feel free to express your interest if some particular thing which you want Krishna to cover. Maybe that input can also be taken. And our survey link is always on. If you also want to present something like this on any topic, please reach out to me. At least express your interest in that survey link. I will reach out to you guys and work out on the details. Thank you so much.
Yeah, thanks, Agresh.
If there's a survey link for the session, that's also good. If there's something right, wrong,
sure, we will
something wrong especially can be corrected next.
Yeah, we'll create the survey for this session also.
Then especially feel free to criticize, no problem. Don't abuse.
Hey, Krishna, thanks a lot, man. It's a good start for SR for the beginners. Thanks a lot.
Thank you.